In this problem, a town's mass burn incinerator has a nameplate capacity of 500 tons per day. A new program begins to recycle newspaper, corrugated board, glass, aluminum, and ferrous cans with an overall efficiency of 50%. The waste stream composition and heating values are given in the table. On a particular day, the measured loss to the incinerator, otherwise known as the daily heat input removed due to recycling, is 500 million BTU per day. What percentage of the incoming waste stream is corrugated board? So in this problem, we are given a few things to start with, none of which has to come from a reference manual. We know the capacity of the incinerator is 500 tons per day, and that half of this capacity is now being recycled for a specific set of items in the table. We also know the total heat loss to the incinerator, aka the total amount of items being recycled, expressed in BTU per day. Given this information, we are being asked to find the percent of corrugated board that is present in the waste stream. Since there are two unknowns in the waste stream, we can't simply sum them all and subtract from 100%. But since one of those unknowns, aluminum, has no BTU value, we can calculate and sum each item and then back solve for what is missing from the total. So let's mark down which items the problem is stating are included in recycling and calculate their BTU per day. We've got newspaper. Eventually we're going to need to solve for corrugated board. There is ferrous cans, aluminum, and glass. So starting with newspaper, we can calculate the BTU per day as follows. The percentage of the waste stream times its specific heating value times the recycling efficiency times the capacity times the unit conversion of pounds per ton to get us to the proper units. For newspaper, this brings us to 360 million BTUs per day. Skipping corrugated board for now, we can move on to ferrous cans. I will write down the new values specific to that specific line item, but reference the constants in order to save time. So for ferrous cans, it's 2.9% of the waste stream and 300 BTUs per pound. If we calculate this out with the other values in the equation, this gets us to 4,350,000 BTUs per day. For aluminum, we don't need to calculate anything since the heating value is 0. And for glass, we have 5% of the waste stream times 60 BTU per day times all of the other values referenced above, and this will get us to 1.5 million BTU per day. Summing these up, we can see that all line items recycled minus corrugated board comes to 365,850,000 BTU per day. So now we are ready to solve for our unknown percentage of corrugated board present in the waste stream. Let's write it out. So our unknown percent in the waste stream times 7,000 BTUs per pound times 50% recycling times 500 tons per day times 2,000 pounds per ton. And that's going to be equal to 500 million minus 365,850,000. Otherwise calculated to 134,150,000 BTU per day. So simplifying the above equation, we can see that we have 3.5 billion BTU per day times X equals 134,150,000 BTU per day. Solving for X, we can find that corrugated board is equal to about 3.8% of the total waste stream, which most closely resembles the second answer on the list. So this problem is pretty straightforward if you can keep track of all the large numbers that you have to calculate and can envision the calculation you need to get to BTU per day. Finally, you need to recognize that you can wait to calculate corrugated board at the end after subtracting all of the other values from the total loss value of 500 million originally provided. And that's it.